Good morning and good afternoon, everybody. Today, we would like to introduce you with what's new in Hawk SP1. SP1 is a service pack release for Hawk, and probably first time we are doing a service pack in Apex right now. Basically, one of the strategic customers have requested for some development in Apex. Not only requested, they also have funded to develop some new technology, and that technology is still MSC's proprietary that we could use for any other customer as well. And while we are doing that development, we also made certain enhancements to the core functionalities of Apex, and hence we thought it could be a good idea to release this one as a service pack 1 for all other customers as well. So what do we have in SP1? You all know that we started supporting what is called NASTAN interoperability in Apex, meaning can we read in the NASTAN BDF, can we export a BDF, can we merge BDF, can we bring CAD and BDF together, etc. And for supporting that kind of workflow, we started releasing the NASTAN interop capabilities beginning last release in Hawk. In the first release, the scenarios that what you create in Hawk in Apex, we were able to export that one as a NASTAN BDF so that it can run in the external NASTAN, and also you could run the same things in the integrated solver as well. So that was the first of a kind export supporting the NASTAN interop. In the current release, we are supporting the ID management, and basically if we were to use Apex for solving any problem, and we would not have bothered about any ID management because we take care of them internally, whereas to export to the NASTAN, we want to make sure everything is unique, for which we need to support ID management. That's what's being introduced in this release, and this is a first of a kind release. Obviously, there's going to be a lot more to do in the coming releases of ID management. And the CBORs and the CRODs are most important element types that needs to be used for this customer engagement that what we developed. And then we thought it's good for every other customer as well. That's why we are introducing the CBORs and CRODs to all of you folks. And what did we do for this particular customer, and what did we develop for them? It is to enhance their customer workflow. What does it mean? And most of these structures that they are developing or building is aero structures, for which they wanted to have what is called the stiffened panels. And it's not only we are giving you the user interface and functionalities to create the stiffened panel, and what customer wanted is to provide the scripting capabilities so that they can automate their best practices. And that's what we did in this release specifically for them, and that is equally applicable for other customers as well. In particular, every aero customer, a shipbuilding customer, predominantly where the beams are used as stiffened panels. And we made some improvements in the composite display compared to the previous release. And we are also adding a lot of scripting capabilities. For example, geometry topology can be visualized through APIs. And you can search with a proximity search to find the nodes, elements, meshes, parts, etc. for whatever the purpose. And you can also do the user-defined highlighting of the parts, and there are many use cases for that one. And also you can define the graphics text to identify the entities on the graphics port. These are the additional scripting capabilities that what we are introducing in SP1. So in the name of ID management, that we are introducing 4 things. One is the model scoped node and element ID uniqueness. What does it mean? and what we call non-volatile nodes and element IDs, and ID display management, and nodes and element renumbering. And in the current release of Apex, which is SP1, we are supporting only the nodes and the elements at this point in time. In the future releases, we will be supporting for the ID management for materials, properties, loads, constraints, etc. And as you know, Apex is a parts and assembly based system. Then we are also introducing the concept of giving an ID budget so that you can define the budget within the parts or within the assembly level. So that any time that you do create model or you do manipulate model, so long as you define the ID budget, it will always be within that range of elements and the nodes, etc., that what we are going to manage. And that is one is going to be coming in the next releases. So what do we mean by the model scope, node and element ID uniqueness in Apex? Generally, anytime that we create the entities in Apex, and it does create unique nodes and element IDs. But however, the things gets complicated when you start importing the NASA and BDF into Apex database. By doing so, there is a possibility that there will be a conflict of nodes and elements that is coming from the imported BDF with the model that already imported, etc. And if that is the case, that what do we do? So if there is any model, if there is any conflict of IDs upon importing BDF, then we would like to offset those NASTran elements that comes in with a default option. However, user have a control on that one, whether they would like to just maintain as is. That means the duplicate nodes and elements can coexist in the Apex database. But however, at the time of export, then you can manage to resolve those ID conflicts, because in the exported BDF you cannot afford to have the duplicate entities. And this was not necessary, like I mentioned, in Apex, because with the integrated solver we could manage internally, but now we need to export NASA and BDF. We need to make sure that we support these things. And what is the definition of non-volatile nodes and element ID? You may have noticed in Apex that sometimes when you create the nodes and elements, that it's not guaranteed to maintain as is if you do any manipulation, such as if you recreate a mesh on any particular body, then you're not guaranteed that whatever the nodes element that you previously created, it's maintained. It may be changed. Or if you move the parts around in the model browser by reparenting into some other assembly structure, then you are not guaranteed to get the nodes and element that you originally created. So that's what we call non-volatile situation, and obviously that is confusing and that is not desirable when you really would like to export the BDF. But now in SP1 that we maintain the nodes and element, that's when once you create it, unless you change it, and it's not going to change automatically. So that's what we define as non-volatile versus volatile nodes and elements. And nodes and element identification, and we are introducing a tool called probe. Basically, you can probe a node or an element. For example, you would like to identify an element or a node in the model because you may have requested some kind of output in your FO6, or you would like to know where exactly that node in your model, and can I find that one? Or you may know a location of a node or an element, and you would like to know where is that one in the model so that it can be exported into a well-defined FO6 or a BDF, etc. For doing that one, we are introducing what is called a probe tool. And nodes and element renumbering, and this has been a long-waited functionality that people have been asking, because particularly in aero industry, that on a given model there will be so many users working on different parts of the model, and finally one person may be assembling all those into one model, and therefore everybody will be working in a set number of nodes and element ID groups, and for which you would like to make sure that you are allowing the user to offset the nodes and element or renumber the nodes and element, etc. And in current build SP1, we are allowing you to do the renumbering only for the nodes and the elements, whereas in the future releases you should be able to manipulate and manage that one for any other entities in your model. With that one, let's take a look at the first demo. Let me import a model. This is typical floor pan model of a ship structure. And since this particular demo is only for showing the nodes and element ID management, let me go ahead and just keep only one of the parts of interest so that we can show how we can manage the IDs. Keep this part only, and let me identify where in the model and change that color so that it is visible better. All right. Let me go ahead and create a mesh for this part. Okay. And in any mesh model, now we are introducing a tool called probe tool. In this one, you can probe either the elements by selection or by ID. Let's first take a look at the label by selection. So if I just grab a bunch of nodes on the screen, it will show you the nodes and element IDs of that selected entities. And if you are interested in only show me only the IDs of the nodes, I can toggle that off to elements, or I can show only the elements, or you can look at the TET elements or a 3D elements and maybe the connectors in the model. You can probe that one, or you can point mass in the model. And these are all the types of entities that we support when we're creating the model inside Apex, and now you can query any of those things in terms of using the probe to look at the nodes and elements connected to any of these entities. Okay, so now you can clear that one, and let's say I would like to label, and I would like to find some nodes in the model. For example, show me where is my node number 10 in the model. Okay, obviously it is showing somewhere in the model, right? But in a complex model, that it may be very difficult to zoom in and zoom out to find where was that ID. For that one, we are giving you zoom to element. Now, for example, I just wanted to look at maybe element 12, and if I do that one, then it will zoom into that element ID 12 of our interest. Okay, or you can even isolate that element upon querying that one. For example, let's take a look at maybe element number 19, wherever it is, and when I do that one, it takes me to there. Since the surface is also on, that's the reason why it is showing that way. So now that is the element ID that I asked for. And here, it's not only, let me toggle it on, surface is on. You can also give that ID not one element at a time. For example, I can give 10, 15 through 25, maybe 100, and show me that. Okay. Now, because we zoomed in and isolate, and it is showing me all the elements that I requested. Okay. It is that simple to identify the nodes and the element either by label or by IDs. Okay, clear that one, and let's toggle it on. All right, let's take a look at the renumbering of entities. And that is done through FEMID tool, renumbering entities. And here the approach is like you can give a starting element ID and a node ID. For example, I would like to renumber the entire model to 10,000 starting node and maybe 10,000 starting element and node. And I can grab the whole part, or I can box the entire thing around. And how do I know that it is renumbered? I can go back to my probe tool and maybe I can zoom in some area. Now you can see all these are all starting from 10,000, right? All the nodes and elements have been renumbered starting from 10,000, right? Even you can query that one, let's say maybe 10,005, where is that one? So it's the same concept, right? Now you are ensured that the entire nodes and elements have been renumbered from the starting node ID and element node ID. That's what you asked for. Okay, so that is what we have introduced in this release, so that you can query the nodes and elements, either the IDs by entering the numbers or by a box pick, etc., through the probe tool and an ID management tool. Okay, let me close that one. Let's go back to PowerPoint. So, continuing to NAST and interrupt, that in this particular release, we are supporting the C bar, P bar, C rod, P rod. And where do you find them in the UI? In the previous release, we gave an option to create the numeric beam shape. And under that one, you have the ability to create, modify, export, and import the C bar, P bar, and the C rod and P bar, C rod and P rod. In addition to that one, even in the P beam element card, you can manage the shear stiffness factors and neutral axis offsets, so that you can visually locate where it is and modify, etc. And that is what is being introduced in SP1. Up till now, in the beam creation tool, that we only supported the constant section, whereas in this current release, we are supporting the tapered sections, and the limitation of this one is the shape at the ends of the beam should be similar. For example, in this case, a hat section should be a hat section both at the end A and B, whereas the parameters could be different, and it can be of any orientation, meaning it can be a curved beam or it could be a twisted beam, so long as the shape at the ends remains same. And that's what's being introduced in SP1. And if you look at any of the aerospace structures, and predominantly they will have the tapered beams, and even likewise in the ship hull structures, most of the stiffeners will have the tapered beams, and hence we are supporting that one in this release. Let's talk about the workflow enhancements. This is predominantly what was developed for us specifically for one of the strategic customer. And what is a stiffened panel? And most products, when I say it is the aircraft structures, could be fuselage or the wings, or the ship structures, the ship hulls, etc., are stiffened by the beams. And these are the beams that predominantly carry the loads. And most of the time, by practice, what you are seeing here is a typical the fuselage section or the floor beam, where they are supposed to supported with the stiffness, right? And predominantly these stiffness are represented by the beam elements. And imagine creating these thousands and thousands of beams manually one at a time, right? That's almost impossible. And also creating these beams and aligned with respect to the plates or the surfaces is always a challenging thing. Excuse me. So we are creating what is called a stiffened panel, in which the beams are created automatically once you assign the shape, and they are getting oriented with respect to the surfaces on which they are tied. And that is typical of aerospace structures, and likewise in the shipbuilding industry for the hull structures, they also have this kind of a stiffness represented by beam, and they are tied to the plate structures, give the stiffness to the members. And there is a slight modification that is done in the Hawk SP1. In the previous release, in the beams workflow, we had the intermediate span and the direct span concept. In SP1, we are kind of eliminating the intermediate span. We are using only the direct span, in which you can create the shape, and that shape can be assigned to an edge or a curve to create the span. So that's most of the workflow has been by the customers, and hence we thought this is good enough to support and this can be removed. And what is the freestanding versus stiffness spans? See, most of the beam creation that what we have today, predominantly they are the freestanding beams, and they can be very well used in a structures like bridges, or also the civil engineering beam of the building construction, etc., where all those beams can be freestanding beams. But when it comes to the aerospace structures or the shipbuilding structures, they are not user friendly, right? Because they have to be connected to the underlying surfaces to give them a stiffened panel. So what did we have in Hawk or even prior releases? So we could create the shape of the beam, and then the shape can be either translated, rotated, oriented, etc., to align properly with respect to the surface. So we could do all those things even in the current release, but doing that one for hundreds of beams, it's not going to be that easy, and quickly it becomes unmanageable. And therefore, we came up with a concept called stiffened panel. So in the beams tool, we're introducing what is called stiffener, and in that one, basically you can create a shape, and it will allow you to define how this shape is going to be positioned with respect to the skin or the plate, whether you would like to have that one on the bottom side or top side of the surface. And once you make that kind of decision visually, then you can say to which curve you would like to assign that shape, right? And with respect to which surface you would like to offset that one. And that's the workflow what we are giving you in Hawk SP1, which makes it a lot user friendly to create stiffener panel. Again, it's not that we are giving you just the user interface to create the stiffener panel, and even to do that one for thousands of beams like structure, it's going to be quite laborious. And therefore, what we are giving you in SP1 is the scripting capabilities, so that using that script and utilizing all these functionalities, we can automate the procedure of creating the stiffened panel beams for hundreds or thousands of such beams in a model. And we are introducing a concept called built-up beams. See, 1D beam elements provide excellent responses for many simulation needs. That's what is being predominantly used. But in some cases, for a fidelity model, then the beams needs to be represented by maybe the shell element or a combination of shells and the beams. For that one, we are introducing what is called the built-up beams, and in which case we are going to create a profile of this cross section using the sketch tool, and then use that profile to sweep along a curve to create these beam elements. I mean, when I say beam elements, beam-like structures by shell elements. It's not that we need to have only the shell elements. For example, in the T section like this one, the web can be shell element and the flange can be still represented by maybe a rod element, right? Some of the customers uses their best practices with a combination of shells and the rods or the bars or the beams, and we are allowing you to create all those things using these what is called built-up beams. And where do we create this one? In the beam tool, in addition to what we had standard beam creation and numeric beam creation, and now we are introducing what is called 1D profile. And using that profile, you can create that shape and you can sweep that shape along a curve to create the beam elements. I mean beam-like structures. Okay, so let's take a look at this demo. Okay. All right, let me load a model, geometry to demo the stiffener. All right, what you're seeing here is a sample representation of a kind of fuselage section where it is curved and also some kind of a tapered shape. And if I hide the surfaces, these are the curves representing the stiffness to be created. And in a conceptual model, that's what the user will start. Where is my skin and where are the curves to which I need to create the stiffened beams. Okay, so let's go ahead and create some beam shapes. And either you can create the beam shapes or you can load the libraries through scripting capability so that you can access those shapes. So right now here, I'm going to create some beam shapes here. For example, in this case, T1, 100, 200, 10, 10. This is the L shape beam 1, beam shape 1, which is L. And let's create another one, maybe another L section in which maybe depth is different, thickness may be different. Okay, I just created another L-shaped beam with a different dimension. Okay, so now let's create one more with the 1D profile, meaning creating a cross section through a sketch. So it will automatically take you to the sketching tool, and let's define the cross section of a profile. For example, I want to start from here, maybe that's the flange. I'm just creating a hat section. Okay. So that is my profile that I created, and we can annotate this section to say, I'm just calling them as some names, You can give any logical names that you want. The reason I'm creating this one, so that I can define what will be the thickness of the different sections of the profile. For example, in this case, maybe the flange will have 10 millimeter thickness and maybe 8, maybe 10. I think I missed the first one as 10. That will be the different thicknesses of that profile. Okay, so we created 3 different shapes. I think I clicked twice, so it created duplicate one. I'm going to remove that one. So we have 3 shapes that we created. Okay, now let's go ahead and see how we can assign these shapes. Let's go to the beam shape 2, that is the bigger section, and create a span. And this is where you can see if I would like to create a stiffener panel, and visually it will show you how that L section is going to be oriented with respect to the surface. This is not the way I would like to create. Is it this approach? Not necessarily that. Is that shape? Not necessarily that one or this one. So that is my required orientation of that beam with respect to the surface. Is it on the top surface or is it on the bottom surface of the skin? And once I define that one, now I can go select the curve and select the surface and it assign to that one. Okay, and let's say I would like to create one. So it's as simple as that one. Okay, and now let me go and assign maybe a tapered beam for the next segment. Where do I do that one? Let me close this, and now I'm going to select beam 1, create a beam span and tapered beam. When I choose that one, it will allow me to define at the end A, I may keep it as maybe the shape 2, at the end B, maybe shape 1. Right? Those are the 2 that what we created. Now I can say assign this one to that curve and that surface. Right? Maybe that curve, that surface. Certainly that's not what I wanted, right? Then I can go here and change it to shape 1 and modify that as shape 2, and I can go and obviously it's going to override that what I created. So that's what I really wanted to assign that shape to that beam, and maybe I can complete that one, and certainly I need to modify that. So make that as 2 and make that as 1 and select that curve that replace. So that's how we created this one. Now let's see how do I assign the one that we created as a profile, right? So where is my profile? That's my beam shape 3, and create a span, and let me see how that's going to show up here. Is that not necessarily it is tapered because it is the same thing, and if you can have this tapered profile as well. Okay, and right now it is showing in a wrong orientation. Do I orient that way? No. Do I orient that way? No. Do I orient that way? Not correct either. Maybe that's the right orientation that I would like to have. Okay, once I did that one, now basically I can select surface and a curve. Where is that? Okay, sorry. So you must have noticed that when I created this one, even though I selected the curve there, and the shape is oriented with respect to that curve, because when I created the profile, that was my starting point, and from which I started like this one when I created the sketch. So certainly when I create a sketch, I would like to see what should be my center point so that I can position that one exactly with respect to the curve, right? But however, you still have your other tools. For example, I could use my transform tool, in which case I can select that one and I can position that how it should be exactly with respect to that. And in case I can even enter exactly half distance or whatever. But do you have the tools to modify that one? Answer is yes. Or you can appropriately create in creating the profile so that it will be positioned properly. Okay. So now what do we have next? We created the shapes and now we need to really render these beam elements for this one, right? And I can hide that shape for the time being. I can go to my curve mesh. Let's say I would like to create the curve mesh with 200 millimeter span for those that I assigned curves rendered shape. So these are the beam elements that I created, and if I assign that one, now you can see those are the beam elements that I created with respect to those curves, right? And I could do the same thing here too. Okay. Whereas these is the shell elements, correct? Now I can use my surface mesh and 200 millimeter for this surface I can create 200 millimeter, and for these two probably even if I want to I can go ahead and create maybe 150 millimeter and for those spans. Okay, now we need to tie these things together, right? We need to connect these things together. There are two options: either we can tie them or we can glue them. And let's say if I would like to tie these beams to the surface, I can go to that tool, edge tie, and I can say those beams to be tied to the surface. So now if you see those beams are tied to the surface, that means the mesh along this edge will be congruent. And likewise, if I want, I can glue these together or I can tie them together, whichever the option that customer would like to do. And the practices are both. Some customers uses whenever there is a shell element, they can glue them together. Whenever there is a beam element, they would like to tie them together so that it will be a congruent. Okay, it is that simple creating these things. Although it looked simple, it is first of all it is accurate, but can we create something like this one for thousands of them? Answer is no, right? For which we are giving a lot of the scripting capabilities. Let me go to the one that I just created before this one. It's the same model I kind of rendered with all these beams, as you can see here, and there are the 1D profile shape that I created for some of these curves, and there are some tapered beams of L section that I created, and also for some curves I did create a Z shape, right, assigned to this one. And then actually to complete this one, I did create okay. I kind of applied the pressure on the skin and then constrained along the boundary so that I can even run this simulation, which I did in this case just prior to this call. Let me see if I can post process that one to see. Displacement seems to be too big. Let's scale it down and contour it, and maybe you can animate. So basically what you are seeing here, along the curves it is stiffened, and in between obviously you can see the kind of displacement, and it makes kind of realistic sense, right? And that's what the stiffened panel is all about. And all these beams now are generative in nature. You can go and change the shape, it automatically updates, or even you can go and change the profile, it can automatically update the mesh. And that is one of the powerful functionalities of Apex, correct? And here, and not to mention, I can toggle the beams, and you can see the beam profile cross section, and they're moving along with the skin. And even if you would like to look at the stresses or the displacements in the beam element itself, you can go to only the 1D beam element. You can toggle that one to look at the display along the cross section of those beams. And in this case, I plotted just the stress. Stress may not be relevant. Maybe you want to look at the forces through the beams or whatever, right? And the concept of the stiffened panel is mainly because you would like to look at the load-bearing members, optimize the load-bearing members, and optimize the load path so that the structure will bear all the loads that it experiences. Okay, that is what this example is all about. And now, just wanted to show how quickly Larry wrote a couple of scripts to mimic the same model, and then with the script, how he was able to create this model probably in a fraction of minutes. Let me go through that just to show you the movie. SP1, stiffened panel, blah, blah, blah. So basically, running the macro, which was created using the scripting capabilities to reproduce the same model here. And in this case, it imports that model and creates those beam shapes and assigns those shapes to the curve. And it's changing the color. Maybe I can fast forward to see. Basically, that's what it is. The script created the stiffened panel. In this case, it is the L-shaped sections, right? And now the second script here is to create the 1D profile, the built-up panels. And so basically, in this case, it created the 1D profile beams. Let me go to the section to see exactly what was created here. Okay, so we created the profile which represents maybe the L shape and maybe some kind of a projection representing that kind of projection onto that L. And that was the profile that was created, and it was kind of swept through the curve to create that stiffened panel. Okay, this is the yet other example of scripting capabilities to automate this process, right? And now it could be any other aero customer. Predominantly, the process would be very similar, and they could use the scripting to automate the best practices. And even in this one, in SP1 rather, we do have the scripts that was used to create what is called the fasteners. So here in this script, basically we are reading the fastener locations. It's just a CSV file. Basically, it gives you the location and where exactly that you have those fasteners to be created, right? And once you read that file through the script, it's going to create all those hard points. And once it creates the hard points, then use the search mechanism through the script again. It will identify which are the parts in that vicinity they are likely to be connected. You can use whatever the logic that you want, maybe the distance logic or maybe the volume logic or whatever, to identify the parts to be connected. And that's what it's doing right now. And once that is done, then the fasteners are configured through the script, whether the fastener should have a C-bush element and an RB2 or an RB3, and that's what is rendered in this case. That means all the fasteners are created at those hardpoint locations, and which has basically a coordinate system, and the springs created, and the springs are connected to the mesh by point to point, right? And imagine that to create this one manually, how difficult it could be. Whereas in the utilizing all the functionalities that's available in Apex, then using the scripting capabilities, then we are able to write these scripts where the assembly of these things can be done in a matter of minutes, like what you saw here. And basically, this is the time what it takes to create this assembly fastness. Okay, so with that, let me go back to my PowerPoint slide. So what do we have in SP1? And in the previous release, we had this composites warp and weft display that was given by some kind of a triad, and it was not user friendly. And in this current release, we are giving you a better display of the warp and weft angle for the display in the composites. And the scripting not only allowing you to create those different panels, and we can use that one to define highlighting or even define some graphic text. Maybe let's take a quick look at that one. Go back to here. I'm going to show you how this highlighting, the scripting is going to help you for what purpose. I'm going to import a geometry model, and in this case it will be highlight. I'm just loading some model here, and then I'm going to run the script to highlight the parts. And what is the meaning of highlighting parts? And basically, the script is going to highlight the parts based on certain logic. And in this case, probably the logic is, let's play macro, highlight. So probably the logic that was used to identify all these parts based on some volume. And based on that one, it highlights in this model, these are the parts are above certain volume. Then you can keep those parts and you can delete all the other parts. For example, in a given model, there could be very many small parts representing the bolts, etc. You would like to delete those parts. You can identify them by highlighting these things, and then you can delete all those small parts. I mean, there are many other user scenarios that one can use to highlight the things, right? And what is the next one is basically the text in the model. Import geometry to display the text. I'm going to import some geometry here, and then I'm going to run the macro to highlight the text. Oh, I should have said no. That's okay. So basically what it did here, the script identified with the tolerance, whatever was used in the script, show me all the edges less than certain dimension. Show me all the faces less than certain areas. That's basically what this script is doing. So using this capability, one can identify maybe the smallest regions in this part, for example, that I don't need to mesh, so that I can identify and I can delete them. I mean, there are many use cases that you can think of for the purpose of highlighting the geometry. So in this case, I'm highlighting the geometry because the geometry has edges and surfaces, right? And it could be any other thing on which you can use highlighting. So that's what I wanted to show in today's example. And I hope that with the SP1, number one, what you can do is the ID management. Number two, what you can do is to create this different panel, predominantly in the aerostructures and the shipbuilding industries, and also using the scripting capabilities that you can automate many of the processes and procedures. With that, thank you very much. I would like to open for questions if any.